Good morning, class. So our lesson for today is all about Planck's quantum theory. So before I start, I would like to give you a brief history about this theory. So in 1900s, Max Planck proposed quantum theory. And what is this theory all about? Good question. This theory explains the nature of black body radiation. So first of all, what is radiation? I would like to share to you my research about this. And radiation is the emission of energy as electromagnetic waves, especially high energy, which causes ionization. And this ionization is the process in which an atom or molecule acquires a negative or positive charge by gaining or losing electrons. So to continue, black body. So I have here a visualization for you to understand it more. It is a hollow metallic shape coated with platinum black and having small hole in its walls which acts as black body. So this is our black body. So this is a body which absorbs all the radiation falling on it. It's called black body. So the metallic sphere at the left part of this body is absorbing. And this is just a representation for you to understand it more clearly. And the characteristics is that it is also a perfect radiator which emits radiant energy. So when we say emits, it means that it releases radiant energy. This is the emitting part on the right side, the platinum black inside. Here it emits energy. Okay, is that clear? Okay, very well. Now, let's go to the nature of radiation emitted by a black body with temperature. So I have here a graph, and this is a graph of for you to understand it more clearly. This is the x-axis and the positive y-axis. So the x-axis represents the wavelength from 0, which is the lowest number, and 3 is the highest. Okay? And the y-axis is the intensity of radiation from 5 to 50. Okay, I would like you to understand it clearly, so I would explain it more clearly to you. So, at any temperature, the intensity increases with wavelength, reaches maximum, then decreases. So, as we can see, it increases, then decreases, right? And as the temperature increases, which means at the highest temperature at 400 Kelvin, as we can see, as the temperature increases, the peak of the curve shifts towards lower wavelength. So the higher the temperature, it shifts towards lower wavelength. So pag mas mataas daw yung temperature, mas mababa siya. The 400 Kelvin. As we can see, it moves upward and it is the lowest point. This is its line, the lowest. Next, the 3000 Kelvin goes higher and then there. And down. 2000 Kelvin, which is the third one. It is the highest of all the three. Okay. So, if the energy is emitted continuously, the curve should be shown as dotted lines. So if it is continuous, shown as dotted lines. Continuously, and it is shown as this. And that if only emits its energy continuously. Okay, so is everything clear of this graph? Now, we're going to move on the postulates of Planck quantum theory. So when we say postulate, it means hypothesis, suggestion, or just a belief. Okay. So the emission of radiation emission of radiation is due to the vibration. Of course, there is a reason for everything. And the emission of radiation is due to the charged particles, which are the electrons in the body. So there are electrons here, and that's why it emits energy. Okay, the emission is not continuous, but take note of this, guys. In discrete packets of energy called quanta, so it is not continuous. Take note of that. And the emitted radiation propagates or extends the form of waves. Okay. So now we're going to explain to you this part of our lesson. The energy associated with each quantum for a particular radiation of frequency is given by E is equals to HU. So when H is equal to Planck's constant, E is equals to 6.625 times 10 to the negative 27 erg per second, and is equals to 6.625 times 10 raised to negative 35 joule per second, and lastly is equals to 1.58 times 10 to the negative 34 calories per second, where U is equals to the frequency of radiation emitted or released or absorbed. So we need to take note of this because it is important in our daily lives and for the chemistry student. Especially we can have a advanced studies about these parts. Okay, so now have here a summary of our lesson for today. So I'll just different molecules can emit or absorb energy in discrete quantities only, meaning it is not continuous. The smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation called as quantum. So this is the summary of our lesson, and I hope that you learned something today and you enjoy our class. Thank you and God bless.